So we have 6xy squared times, this is 2 raised to the power 2, which is 4, x raised to the power 2 x squared, and then y raised to the power 2 y squared, and divided by 8x squared y squared. Definitely this x squared y squared is gone with this x squared y squared, and 8 here with the 4 will give us 2, and the 2 with the 6 will give us 3, and that's it. So we have 3xy squared. So this x is raised to the power 1. They just wanted to find out if you know that there's a power here, an invisible power. So you're having ax, 3 as a, m as 1, and n as 2. Same thing here. This is 2 times 3, 2 raised to the power 3, which is 8, and then we have times 3 there, and then we have x raised to the power 3, but times x here will be x raised to the power 4. So we have that, and then we have 6x squared. So this is 6 raised to the power 2 is 36. And we have x raised to the power 2 times 2 x raised to the power 4. So we'll clear this x raised to the power 4 and x raised to the power 4. We have 3 into 36, which is 12, and this is 3 here, and then this is 8, which is 4 into 8 is 2, 4 into 12 is 3. So our answer is 2/3. Okay, so this question here can be a no calculator question, because 82 times 3 is 246. You can do that easily. 3 times 2 is 6, 3 times 8 is 24, 246. And if you remember, you're having all the zeros at the back, 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 zeros, 1 2 3 4 5 6 7 zeros. So 2.46 times 10 raised to the power n. We need to make this in standard form: 1 2 3 4 5 6 7 8 9. So we have 2.46 times 10 raised to the power 9. So the value of n is 9. Let's move on to the next one. So here we have this equation: which of the following is equivalent to the expression shown above? So this is quite so all you need to do here is to expand this a times 2 to a minus a squared. Expand each of these and then subtract the ones like terms. Minus a squared plus a squared is gone, and stuff like that, and get whatever answer you come up with. Alright, question number 2. So minus m squared n squared minus n squared plus 3m n squared minus m squared n minus n squared plus mn squared. So which of the following is equivalent to the expressions shown above? So when you do this, you just simply multiply negative of this. So this is where this is the main one here: minus m square n minus minus will give you plus n square, and then minus mn square. So if you look at this, minus m square n, this is it, minus this is minus 2m square n. Then we have minus n square plus n square, that's gone. Then we have plus 3mn square minus mn square, that will give you plus 2mn square. Alright, I think you have already seen your match. Here is it. Here it is. See. So here you have the same thing, no difference. Here will just become plus 2x squared plus 3x. Okay, and after you do this, you are going to get an equation that looks like this. just know the position of your A, and you know the position for your B, and the position for your C, and add them together and you get the answer. Okay. So there are many ways of doing this division. There are many ways of doing the division. You can either do it this way: x into x cubed, you have x, multiply x times x minus 1, you have x squared minus x. Then you subtract it. You can see that this x squared and this x squared here is going to eliminate it. So you're still having x cubed, because this minus x, this is minus this x, and this x will go off too. So we still have x cubed, and we have minus 3, x cubed minus 3 and plus 3. So but let's just give it 3 minus 3. So we have x into this again, we have x squared, x into that, we have x squared, multiply it again, x times this, you have x cubed, no, x squared times this minus x squared. Scrap that. So in this one, you first use x into x cubed, we are going to have x squared. But you multiply this, you're going to be having x cubed minus x squared. Okay, so when you try to add them together, it is going to eliminate things like this x cubed minus, this is x cubed, my x cubed minus x cubed is gone. Then you have minus this x cubed, minus is the same thing as subtracting it, because minus is plus, minus x squared plus x squared is gone. So what you are left with is 3x minus 3. So let's go with x into this. If you go with x into 3x, you'll be having minus 3. So multiply 3 minus 3 times this, you'll be having 3x minus 3. See, minus 3, you have 3x minus 3 times x is minus 3x minus 3 there. Okay, how we would know that our division is correct? How we would know that our division is correct is by testing it. If you multiply x squared minus 3 times x minus 1, you should be able to get this. You can also do it by factorizing, because these are the two factors, x minus 1 and x squared minus 3, which is actually x squared minus 3 and x minus 1. So you have this x squared times this x will give you x cubed, x squared times minus 1 will give you minus x squared, minus 3 times x will give you plus 3x. So you find out that it is not actually minus, but actually it's a plus. Then plus 3 times x will give you that plus 3x, and then plus 3 times minus 1 will give you minus 3. Then now you know that it's x squared plus, it's a plus, not a minus. Here it's a plus, not a minus. And that's 3 times this x will give you 3x plus 3x, and then 3x times minus 1 will give you minus 3. And that's why when you subtract it, you are going to have 3x minus 3x, which is 0. Minus 3 minus minus 3 is still 0. So this is how you can divide. You can divide it that way. You can use this division. We'll test another question with it so that you understand the importance of this. So we have this. In the question above, a is a constant and ax minus 1 is not equal to 0. What is the value of a? So we have 14x squared plus 9x minus 20 divided by ax minus 1. And we have it equal to 7x plus 8 plus minus 12 over x minus 1. Alright, the very first thing we could easily do here is to multiply everything through by x minus 1. But that is going to be really hard to do, because it's going to be quite complicated. Okay, so Another thing we can do, we can divide everything by ax minus 1, but that's also going to be annoying. But let's see, we can multiply everything by ax minus 1, but we can be careful about how we multiply by ax minus 1. What do I mean? Let's multiply everything, and when we mean everything, we are talking about multiplying each individual term by ax minus 1. Now, because this is divided by this is the same thing as writing 14x squared plus 9x minus 20. This is the same thing as then divide it by ax minus 1. Divided by ax minus 1. Okay, divided by x minus 1. This is the same thing. So this is just one term, because this is you are dividing it. It's just one term. It's not individual term like this plus. You see this plus means that individual terms separated, because you can move them easily. But this one is a single. This is a single term here, and that's what this one means. So if you multiply everything through by ax minus 1, if you multiply everything through by ax minus 1, you are going to eliminate this ax minus 1 in here. You're going to eliminate it. Okay, and then each of these places will be multiplied by ax minus 1, ax minus 1. Alright, let's do that real quick. So when I multiply ax minus 1 times this, I'm going to clean up this ax minus 1. So I'm having 14x squared plus 9x minus 20. Let's write that out. 14x squared plus 9x minus 20. Okay, now we know we are multiplying it by each of the term. Ax minus 1 times 7x, we'll be having 7x times ax. That will be 7ax squared. 7ax squared minus 7x. Okay, then multiplying 8 times this, we'll be having plus 8ax. Then 8 times minus 1 is minus 8. Then if you multiply it through ax minus 1 times this other one, you're going to eliminate the ax minus 1 under, so you just have minus 12 at the base. So here we're having things that look similar. We can rearrange this to make it look fine. I'm going to carry minus 7x to the other side, and you get 9 plus 7x. So that will give you 9 plus 7 is 16. So we have 14x squared plus 16x, okay, plus 16x minus 20. Minus 20. You see, minus 8 minus 12 here is minus 20. You have minus 20 here, you have minus 20 here. That means they can clear out each other. So you're not gonna take it off. So ignore that. So we now have a 7ax squared. 7ax squared. We have already eliminated the minus 7x out of the picture. We also eliminated minus 8 and minus 12. So just as we did this. So we have 7ax squared and plus 8ax at the end of the day. So if we are seeing this way, 7ax squared plus 8ax, whatever is here, this 7a, because this x squared is same thing as x squared here, that means 7a is related to 14, as well as 8a is also related to 16, since x and x are the same. So for 7a to be 14, that means a is 2. For 8a to be 16, that means a is 2. So a is 2. A is equal to 2. Let's clear this up. Alright, this is similar to the other one. So similar to the other one. Do the same thing here. Use this, multiply it through by this, you clear this out. Use this, multiply by each individual term, clear it out, just a left. Solve it. Look for the constant term, the term. Look for what is relating the two sides together, and you'll get it easily. So we have this, which of the following is equivalent to the expression shown above. So we have x plus 3x minus 5, and this is it. We also have this. Alright, so how can we do this easily? You can do this by either you expand it first, okay, x squared okay, plus minus 5x rather, plus 3x, minus 5x plus 3x, and then you have 3 and times minus 5, that's minus 15. Okay, so minus 5x plus 3x will give you minus 2x. So you have x squared minus, this is minus. Alright, so this is your difference of two squares method. This stuff you're seeing here is difference of two squares. Now, how is difference of two squares solved? You equate whatever equation you have, this equation you have equal to 0. Then you're not going to do half of the addition of x, half of the coefficient of x. Half of the coefficient of x is minus 1. This is the coefficient of x is 2. Half of it is minus 1. So you're not going to add that to each of them. So you have x minus 1, just raise it to power 2, okay, is equal to, carry minus 15 to the other side, you have 15. Then you're adding half of the square. The square of minus 1 square is plus 1. So you are going to be adding 1 to the other side, plus 1 to the other side, plus 1, and this will give you 16. If you return it back, you'll be having x minus 1 all square, x minus 1 all square minus 16, which is C. This is the answer. Let me explain this one more time. I need to explain it. When it comes to solution of equation of difference of two squares, what you are doing is that you first of all you write out the equation. The equation of this one is x squared minus 2x minus 15. Equate it to 0 because it's a quadratic equation. Now, the first thing you're going to do is get half the coefficient of x. Half of the coefficient of x. My coefficient of x is minus 2. Minus 2. Half of the coefficient is minus 1. Now square it. I have minus 1 square. What you are going to write? You are going to once you have gotten it, you are going to eliminate this. This is no longer a part of your equation, but you are now using this. Now you are going to write x squared minus this thing here, whatever this is, minus 1 square. Now carry this minus 15 to the other side, you have 15 already. Now that thing that you have, this minus 1 square, finally get what it is. Minus 1 square is 1. So now add it to this 15 that's here. That is the step. Add it to the 15 that's here. You get plus 1, 16 there. So now look at this. X squared minus 1 square, it can be written as x minus 1 all square. X minus 1 all square. So it's equal to 15 plus 1 is 16. Now x minus 1. Normally the next thing you are supposed to do is to square root this. Is to square root it. Okay? When you square root it, that's what you are supposed to do. And when you square root it, you will now move minus 1 to that side. But they are not looking for you to solve it. If you are to solve it, you have to first square root it. When you square root it, you get 4. Okay, I now say x is either 4 minus 1, that is 3, or x equal to 4 plus 1, that is 5. So you are either that, but here you are not looking at that. You just want to get this equation, x minus 1 square. If you move this thing, you get this. If you move it back into here, you get minus 16, and that's your answer. Alright, let's go forward. So which of the following is equivalent to the expression shown above? So we have this 2 minus 5x, 5x plus 2. So we're going to multiply this to give you 10x plus 4 and then this minus 5 times 5 is minus 25x square, 25x square, and then minus 5x times 2 is minus 10x. So we have 10x plus 4 minus 25x square minus 10x. You see, this 10x minus 10x is gone. So you have 20 minus 25x squared plus 4, or 4 minus 25x squared. So you have minus 25x squared plus 4, which is B. Here. Now, how do we know that this is correct? Remember that if you from what you are solving here, each of this is equal to 0, and so is each of this is equal to 0. Each of this is equal to 0. So minus 25x squared plus 4 equal to 0. So move plus 4 to the other side. You have 25x squared. Move the negative 2 is equal to 4. Because if you move this to plus 4, you have minus 4. Cancel the negative, you have 25x squared equal to 4. Now the very next thing you do is to divide by 25. So you have x squared equal to 4 over 25. We're not solving anymore. We've already got an answer. I'm trying to show you something. This is 4 over 25 equal to x squared. Now the next thing you do is x is equal to the square root of 4 over 25. The square root of 4 over 25 is, there can be two things. The square root of 4 over 25 can either be plus or minus. Square root of 4 is 2 over 5. So your first answer is plus 2 over 5. And when you rearrange it, you have 5x minus 2. See that 5x minus 2, or minus 2 for 5x, anyhow you want to do it. And then got it now. That's x equal to plus minus 2 over 5. Let's go. 5x minus 2. 5x minus 2. If you move it, because it will be plus 2, 5x equal to plus 2. Move it, 5x minus 2 equal to 0. So you have 1. Then you do the second one, 5x minus 2. And you move it, 5x plus 2. 5x plus 2. Let's say we have two quadratic equation. We have two roots, 5x minus 2 and 5x plus 2. That's what it is. And if you turn this, minus 2 plus 5x, 5x minus 2. Alright, here's another question. Which of the following is equivalent to the expression shown above? This is it. Okay. Now, some persons usually get confused when they see this kind of thing. Like, what are they going to do? Just solve it like normal quadratic. Multiply the first and the last term. When you multiply 4 times 9, you're going to be having 36. 36x squared y squared. Now you ask yourself, what are the two numbers that when I multiply, it will give me 12? Or when I multiply it to give me 36, or when I add it up, it will give me 12. Everybody know those two numbers are 6 and 6. Like if I multiply 6 times 6, 6 times 6, I'll be getting 36. That's like minus 6 times minus 6. Okay, you'll be getting 36. And if you are doing minus 6 plus minus 6, you're getting minus 12. So let's put in the other functions in there. Minus 6xy times minus 6xy. If I multiply this, it will give me this. Multiply xy, give you xy, y squared. While if you are adding it, it will give you minus 12xy. So let's write it now. We're having 4x squared. We're solving it exactly like a quadratic equation. No difference. 4x squared minus 6xy minus 6xy plus 9y squared. Now let's solve that now. Let's solve that. You have 2 rather into 2x. Like let's keep x out. I think we should keep x out here. 2x into 2x. Okay, 2x into 2x minus 3y. That makes sense. So put another 2x minus 3y here. Now what we'll be having is minus 3y because minus 3y times give minus 6xy, and minus 3y times minus 3y give you 9y squared. So we have 2x minus 3y, 2x minus 3y. We have it twice, and if you're having it twice, 2x minus 3y, if you're having it twice, it's like multiplying it by itself, so that it's just by raising it to power 2. So 2x minus 3y all square. 2x minus 3y all square. That's it. That's D. Alright, let's solve question number 6. So here we have 2 raised to power a minus 1, a plus 1, and 2 raised to power a minus 2, a plus 2. Now, because they are the same, these 2 raised to 2, the base are the same, so we'll just be handling the top. This is the exponent. A minus 1, a minus a plus 1, a minus 1, a plus 1, and minus, remember it's minus a minus 2 into bracket a plus 2. Now, if you can remember sum and difference of two squares, you understand what is going on here. This is the classical definition of sum of two squares: a square minus 1 square, while this is a square minus 2 square. So a square minus a square there is gone, and this is minus 1 square minus 2 square. Minus 1 square minus 2 square, what is that? This is minus 1 minus 4. It's so wrong. This should be in bracket. Yes, this should be in bracket. So we have a square minus a square. Yes, it's gone. Minus 1 minus that's minus 1 plus 2 square, that's 4. Minus 1 plus 4 plus 3. I think there's a problem somewhere. It's wrong. Alright, so that's it. 3. So that's 3. We have 3. Everything in the index is 3. But remember, we're using the power. So we have 2 raised to power 3, and that is 8. Remember, this is when we're doing the index, we subtracted, because we're only handling the index. 2 over 2 is 2 raised to power whatever is up minus whatever is down here, and that's 2 raised to power 3. We're just getting only the index, and that's 8. Alright, let's go to the next one. So here you have one more. Which of the following is equivalent to the expression shown above? And actually, this has to do with prime factorization, GCF, and LCM, and how well you can manipulate them. So even asking which of the following is equivalent to the expression shown below, you can easily get the LCM, or the LCM of between 42 and 63. And if you look at that very well, that's 21 is times 2 here, and 21 is times 3 here. So 21 into, you see, x is common, so we should have kept 21. X is common into x, yeah, x y square plus, sorry, that's 2xy square. Okay, 2xy square plus 3y square, 3y cube. It could also be 21xy into 2x plus 3y. This could also be square. You can also square this, 2xy squared, 2x plus 3y. It's okay, and that's what this one is. Yeah, So you have several ways of writing it. This question just wanted to know how well you can manipulate your algebra. Okay, I'm pretty sure you can solve number 9. I'm totally confident you can solve question number 9, and even question number 2 rather. You can solve question number 2 and question number 3, and I'm sure you can also solve question number 4. But let's try it. If x and y are positive integers and 12 raised to the power 3 equals to 2x times 3 raised to the power y, what is the value of x raised to the power x plus y? So you're looking at this 12 raised to the power 3 there, knowing fully well that you can also split this. You can split this, and you can split this into 6, or let's say 6 times 2. You can also split it into 3 times 4. You can split that into 3 times 4, and then you raise it to power 3. It's equal to 2 raised to power x times 3 raised to power y. 3 raised to power y there. Times y. Okay, so another thing, if you look at your number 4 there, you can also reduce that your number 4 to 2 raised to power 2. So we have times 2 raised to power 2, so that it will look like the other one there, and this is 3 raised to power y. So what we're going to do, we're going to write 3 raised to power 3 raised to power 3 times 2 raised to 2 raised to power 2. 2 times 3 outside will give you 2 raised to power 6. So we have 3 raised to power 3 times 2 raised to power 6 is equal to 2 raised to power x times, you already know x is 6, times 3 raised to power y, and you know y is 3. So let's proceed. This other one is also similar. 2 times 5 raised to power 9, k times 5 raised to power 8. 2 times 5 raised to power 8. What's the value of k? Now what's confusing is that this is minus here, but knowing fully well that you have 5 as one of the numbers here, you can use 5 into, now this is 5 raised to power 9, so if you can put 5 raised to power 8, but you should know that if this is 5 raised to power 9, you can put 5 raised to power 8 times 2 times 5 raised to power 1, which is times 5, minus k times 5, just times k, because k, this is k raised to power 5 by 2. You just have times k there, minus k there, and we'll put this in bracket here, equal to 2 times 5 raised to power 8. Now we have 5 raised to power 8 in 2 places. You have it here, you have it here, so you can clear it out. So we have 2 times 5 minus k here, that's like 10 minus k is equal to 2. It's quite simple now. 10 minus k is equal to 2. You never need to get this simplified. So 10 minus k equal to 2, and move minus k to the side, move 2 to the side, you have k is equal to 8. Equal to 8. Alright, so let's move to the next one. Next one is 12 raised to power 99 minus 12 raised to power 97 equal to 12 raised to power 97 times n. So same thing, you just do exactly the same thing. 12 raised to power 97 into 12 raised to power 2 minus this is a no calculator section, of as you could see. So 12 square minus 1 is equal to 12 raised to power 97 times n. So you cut this off, you have 12 raised to power 2, which is 144. 144 minus 1 is 143. So we have 143 equal to n, and that is your answer. So here we have 1 plus 2x minus x into 1 plus 2x, where we are trying to use what we call the distributive property. We'll explain what that is. So 1 plus 2x minus, this is x minus 2x. So we have 1 plus 2x minus x minus 2x square. Okay, minus 2x square. And what we can deduce from this is that it's almost like this is a quadratic equation. So we can easily solve it like a quadratic equation. So here we're having 2x minus x minus 2x squared. And if you look at the first and the last term, this is it. 1 times minus 2x squared will give you 2 minus 2x squared. And if you have plus 2x times x minus x will give you minus 2x squared. And if you add them, 2x minus x squared, it's definitely give you whatever you're gonna do now. So you know that this is a quadratic expression, but the only problem is that it wasn't organized to look like a quadratic expression. You have not factorized it yet, so they just want us to be able to factorize this. Probably one of the issues in factorizing this is the arrangement. So let's arrange it properly. So we have 1 minus x plus 2x. We can rearrange that. Yes, we are always allowed to rearrange. Minus 2x squared. Okay, so we have 1 minus x plus 2x squared minus x. Here we can easily solve this by putting 1 into 1 minus x. Alright, put that same 1 minus x here. We have 1 minus x. And what do you think will work here? We have 2x. 2x times 1 is 2x. 2x times minus x squared is minus 2x squared. So our two numbers is 1 plus 2x and 1 minus x. 1 plus 2x and 1 minus x. And that is it. Look at B here. So the problem is there was just the arrangement here. So here, what is the value of x if rx plus sx equals 3 and r plus s equals 1 over 3? So this looks like a simultaneous equation, but you have to be careful. This is x into r plus s. R plus s will be equal to 3. So if r plus s here is 1 over 3, just simply drop 1 over 3 here. 1 over 3 equal to 3. So this will give you x over 3 equal to 3. Carry 3 to the other side, you have 9. X equal to 9. And that makes much sense, because put 9 into r plus s equals to 3, and r plus s is 9, so you have 3 over 9, 1 over 3. So r plus s is 1 over 3. That makes more sense. Alright, so let's go to the next one. So you have one question here. Which of the following is equivalent to the expression shown above? 2x minus 6a minus 3x plus 9. Alright, this is also not arranged properly. Move this to this side and move this out here. So you have 2ax minus 3x minus 6a plus 9. So here we are having you can make here 2a into x minus 3. 2a into x minus 3, because it's 2ax. Okay, and let's put it, I think we should put an x here. Let's wipe that. I think that's not correct. Let's do that again. 2x. That's like, I don't think we should make a label to it. Let's give it x into 2a minus 3. I'm gonna put 2a minus 3 at the other side too. 2a minus 3. I think solving this, we have minus 3 times 2a, that's minus 3 times 2a, that's minus 6a, and then this is plus 9. So you have x minus 3, you have x minus 3 and 2a minus 3. This makes more sense. Yeah, x minus 3 and 2a minus 3. Alright, let's go to the next one. So here we have mn minus 5n minus m plus 5. The following is equivalent to the expression shown above. Exactly the same thing. Arrange it first and then factorize it carefully. From what we're doing, we could also solve. You can also solve number 5 just by arranging it carefully. Rearrange it like rearrange it very well before you factorize. When you arrange it, you factorize easily. Try your hands on number 6. And just below this you have your chapter 10 practice test. I would like you to really solve your practice test, and let's see if you can get up to the maximum score of 12 over 12. I'm praying you get 12 over 12.